One step at a time, I'm going to go through how to graph a quadratic function that is given in standard form. So we have the function f of x, which is equal to 3x squared plus 2x minus 1. This is standard form, where a is 3, b is 2, and c is negative 1. Standard form means that the exponents are going from greatest to least. So I'm going to go through all the different features of this graph and how to find each of the features, starting with whether this graph is going to be facing up or down. That's where I would start, just so you have an idea of what this is going to look like. So it says that it is opening up if a is greater than 0, and it's opening down if a is less than 0. In other words, if a is a positive number, it's going up. If a is a negative number, it's going down. So in this case, a is positive 3, which means this is going to be facing up. So it'll look something like this. Now, just a side note, this is going to have what we call a minimum. The vertex is a minimum because it's facing up. So the vertex would be considered a minimum in this graph because it's the lowest point. Next, we'll talk about what's called the axis of symmetry. The axis of symmetry is what cuts the graph right down the middle in half. It's a mirror image across each side of the axis of symmetry. The axis of symmetry goes right through the vertex. So to find it, you just plug in these values. X equals negative b over 2a. So b is 2, so we have a negative 2. And a is 3, so we have 2 times 3 in the denominator. So we end up with negative 1/3. Now, something that you need to remember is that the axis of symmetry is a line. So if you just write negative 1/3, you're not telling me enough information. You have to write x equals negative 1/3 as your axis of symmetry. So one more time, you need to make sure that you are writing x equals, not just the number. Next, we'll talk about the vertex. On the last slide, I told you that the axis of symmetry the axis of symmetry goes through the vertex. So that means the axis of symmetry's x value is actually the x value of the vertex. So once you have your axis of symmetry, you can plug it in to the function to find the y value of your vertex. So again, all we're doing is plugging in the axis of symmetry, negative 1/3, to get the y value of the vertex. F of negative 1/3 means that every single x in the function is becoming negative 1/3. And now you need to remember your order of operations. Exponents come before multiplication. So make sure you're squaring negative 1/3 before you do anything else. When you square a fraction, you can square the numerator separately from the denominator. And since this is a negative being squared, it's going to equal a positive. So 1 squared is 1, 3 squared is 9. Again, this needs to equal a positive number, so we end up with positive 1/9. And now I'm going to multiply my whole numbers with my fractions by putting the whole numbers over 1 and multiplying straight across. So in the first one, I have 3 times 1 over 1 times 9. In the second one, I have 2 times 1 over 2 times 3. Sorry, I don't know why I put a 2 there. Over 1 times 3, sorry. This is going to be negative. So again, 2 times 1 over 1 times 3. and we've got the minus 1 afterwards. Now we're going to need common denominators here. I know that 3 over 9 reduces to 1/3. I already have minus 2/3. And then 1 is the same thing as 3 over 3, so I'm going to rewrite this as negative 3 over 3. So we have 1/3, minus 2/3, minus 3/3. Just combine your numerators. The denominator is still 3. So we have a y value of negative 4/3. So please do not circle negative 4/3. That's not your answer. Remember, we're trying to find the vertex, which is the point at the lowest part of this graph in this case. So the x value of the point is negative 1/3. The y value of the point is negative 4/3. So that's our vertex. That's the lowest point of this parabola. Next, we are going to find our x-intercepts. Remember, x-intercepts are what you get when you set y equal to 0. And now we have options. We can factor, we can use the quadratic formula, or if you really want, you can complete the square. My suggestion would be to try to factor first before anything else, because factoring is going to be your quickest method. So if we try to factor this, I'm looking for two numbers that multiply to negative 3 and add to positive 2. My voice just went out there. So there are two numbers that multiply to negative 3 and add to positive 2, which means this is factorable. Positive 3 and negative 1 are your two numbers that multiply to negative 3 and add to positive 2. Now I've got this 3 in the front that I need to divide back out. So we end up with x plus 1, 3x minus 1. And remember, we're finding x-intercepts here, so we're going to set each factor equal to 0 and solve for x. I trust that you know how to solve for x by now. So in the first one, if we have x plus 1 is equal to 0, that means x equals negative 1. And in the second one, we have 3x minus 1 is equal to 0. We're going to add 1 and then divide by 3, giving us 1/3 as our other x-intercept. So this is going to cross the x-axis at negative 1 and positive 1/3. The last thing that we are going to find is the y-intercept. The y-intercept is what you get when you set x equal to 0. Now, if you're multiplying a bunch of things by 0, they're going to disappear, which leaves us with negative 1. So our y-intercept is negative 1. And going forward, just a shortcut, if this is in standard form, which this one is, the c value will always be your y-intercept, but it has to be in standard form for you to do this. So now that I have found everything, I'm going to put it on the graph. Remember, our vertex was at negative 1/3, comma, negative 4/3. So it's not going to be exact, but that's approximately where the vertex would be. Our x-intercepts were at positive 1/3 and negative 1. Our axis of symmetry goes through the vertex. So we usually use a dashed line there because it doesn't actually exist. It's more of an imaginary line going through the parabola. And then finally, our y-intercept was -1. So now connect your points and you have your parabola.